Max Panas, everybody.
Are ready. Hey, so I'm so glad to be here today. Honestly, I wanted to thank the organizers for putting this together and for giving me the chance to come here on this sunny Athenian morning to talk to you about something that I've been excited about for a really, really long time. My name is Max Panas, and I'm a software engineer at Camelot Global in London. 6 short years ago, I remember I was back here in Athens interviewing for positions as a web developer. Funnily enough, one of the guys who is interviewing me is in this room at the moment, so you can blame him for me standing here right now. At the interview that finally got me the job, I remember they asked me whether there was any modern tech in JavaScript that I was particularly interested in. I remember at the time I sat opposite them and said, well, there is this one thing. And that one thing is called Service Worker. I've been reading a lot about it, and it looks kind of interesting. I remember none of my coworkers got particularly interested about that at that point in time, but it seemed to be enough to get my foot in the door. So that was a good thing. Fast forward to today, and in software terms, it has been a long time since the interview, and service workers have come an incredibly long way since then to become a central part of what I'm going to be talking about today, progressive web apps. So I'm incredibly excited to be here right now to talk to you about this topic, just as it's finally beginning to hit the mainstream. In fact, some people have called 2018 the year of the PWA. And honestly, I think it's quite hard to argue with them. Over the past few years, big and small companies have tentatively been approaching building PWAs, and what was always promising was that even early adopters found notable success. In 2016, Flipkart, probably the first high-profile adopter of PWA tech, launched their website as a progressive web app. Then, one after another, Twitter, Pinterest, and Uber released web experiences that took advantage of PWA technologies. And finally, this year, in 2018, we've seen an incredible influx of success stories pouring in from established brands as they dip their toes or dive right into the world of progressive web apps. PWA technologies like one-click sign-in, service workers, and web payments allowed Starbucks to create a web app that is installable on your phone's home screen and lets you initiate orders even when your device is offline. Add to home screen, service workers, web camera APIs, web payment APIs powered even more success stories. And finally, service workers have this year even made it into the most visited page on the internet, the Google search page. PWA technologies allowed Google to make 50% fewer JavaScript calls on the page, as well as allowing users to resume searches made offline. And what I find very exciting is that these companies have been using the technologies that define PWAs in sometimes very, very different ways, each striving to achieve the most impact for their particular problem. This highlights for me a very important aspect of PWAs, the fact that they define a group of behaviors, features, and technologies. They are not a framework or a library, they are more of a concept. Not one thing, but a group of things. So you don't need to feel like you have to use every single piece of technology under the PWA umbrella. But you can pick and choose. Select the ones that make your user's experience measurably better and progressively make the web a better place, one little manageable piece at a time. So why now? Why has this year seen so many companies publish success stories with PWAs and so many more embrace the technology wholeheartedly? And more importantly, perhaps, why should you all start picking up your keyboards now and adding this tech to your apps and sites? For me, it is 3 things. 1, we have proof that it works, that it is effective at delivering what we crave the most, value to our customers. We've got the proof through the case studies published of the companies already using it and the articles of the developers working with the technology already, that amongst others, it helps in performance, user experience, and of course, your web app's bottom line. We know it works well and looks good, surprisingly good. Go visit mobile.twitter.com on your phones and play around for a little while. That site's a PWA. You can even install it on your home screen, and it, like many of the others, looks great. 2, the tech is ready. The APIs are mature. They are by no means done and finalized, but they are most definitely ready for production. And moreover, there are a multitude of really great tools and tutorials available to make it even more straightforward, not only to get started, but also to let you do really fine-grained optimization on anything you might make with them. And perhaps the most compelling of them all, the core APIs are now supported across all major browsers. This actually became a fact while I was preparing for this talk. Chrome, Opera, and Firefox have supported many of the PWA technologies for quite a while now. So it was great to watch as the remaining browser vendors, one by one, released updates that added support in the months and weeks leading up to this talk. First, sometime around March, Apple announced the Safari and iOS Safari 11.3 would come with Service Worker and Web App Manifest support. And then, just a few weeks ago, Microsoft came out with a couple of great announcements that Edge had added support and the PWAs were even going to be treated as first-class citizens in the Windows App Store. That means that your users will be able to use the App Store to download PWAs that you've just distributed through the web. This year, it all seems to be coming together. Browser support is increasing, the tooling has matured, and there's a huge pile of proof that PWAs plain work. In fact, and after this talk is done, I hope you agree with me, that even if 2008 was not going to be the year of the progressive web app, we should work hard to make it so. So, what is a PWA? As I mentioned earlier, the term progressive web app is more of a concept than something extremely specific. The term was coined by Alex Russell and Francis Berriman about 3 years ago, inspired in part at least by the work that was already being done on the Service Worker and Web App Manifest specifications. Alex then put together a thought piece to specify a list of goals that a website should aim to achieve in order to optimize the user experience for the modern web, where user standards regarding connectivity, interaction, and performance are higher than ever. These web apps of the future needed to be responsive. They needed to fit any form factor. They needed to be able to work well even when the network was slow, intermittent, or even completely unavailable. They needed to be interactive in ways that we are used to from native apps. For example, they should not re-render the entire page when navigating, but also they should have access to device-specific sensors and capabilities like camera, payments, and geolocation. They needed to be easy to update with new content and even new functionality directly over the internet without going through an app store. They needed to be secure. They needed to be indexable and directly available when the user searches for them with their search engine of choice. They needed to utilize engaging native functionalities, such as home screen icons and push notifications. They needed to be installable on the user's devices so that they are directly accessible. And finally, and very importantly, they needed to still preserve the greatness of the web that is its linkability. Sharing a page from within this futuristic app should be just sharing a URL. For a lot of these, service workers are the true backbone to implementing the vision. Because they can intercept and respond to every request our page makes, they give us the ability to control exactly how our site works without a network connection and give us new powerful tools to improve our app's performance. And because they work in the background, they can receive events such as push notifications and geofencing updates, even when the user doesn't have our page open. So, how do you start? Well, the beauty of it is that whether you've got an application already or you're just planning to start out with something brand new, adding your first sprinkle of PWA functionality is no big deal. The first thing to keep in mind is that the concept of the progressive web app is an addition to the web platform. It builds on and does not replace the current industry standards. In his article, Alex makes a point to highlight that Francis and his concept for the future is at its core based on the industry's established best practices. Responsive web design, web accessibility, and web performance are just as much a part of the PWA's story as service workers and push notifications. Focusing on and optimizing first meaningful paint, time to interactive, eliminating stuttering in animations, making your site accessible to all humans and robots, and making your site look good on devices of all kinds, from watches and mobile phones to desktops and televisions, is as important as it ever was. Another cornerstone of the PWA concept is progressive enhancement. Progressive enhancement means that you should be designing and developing your website with the most basic user in mind and progressively enhancing your app's capabilities as support for them is detected. Inclusivity is an important cornerstone of the web's culture. So, if you're working on something existing or new, it pays to make sure you have covered these core areas, and you always consider the addition of new tech through the prism of how it will benefit your users. Having said that, PWA tech is so compelling, it is really quite hard for me to imagine a scenario where you would not want to add a little bit of it. So let's get on to the next step. The second bit of setup, and this one is important, is that your site or web app needs to be served over HTTPS. If your site is not, then why not? Nowadays, HTTPS can be a matter of 30 minutes to set up. As mentioned earlier, one of the core tenets of the PWA experience is that it strives for security. As such, it was decided very early on that because of their capabilities, a lot of its underlying technology would be delivered over HTTPS only. As with any software, HTTPS is not an absolute guarantee of security, but it does provide a very important improvement over regular HTTP and is thus an absolute baseline for what is required for security on the web today. Further securing your site for both yourselves and your users is a very important topic and one you should dive into deeper when you have the chance. I want to shout out to Scott Helm on this one for his work he has done in making some of these techniques accessible to people like me without a deep background in information security. His blog, yearly reports, and reporting tools are really great for getting started with your site's security. At this point, you're finally ready to create your application service worker. This piece of code is probably going to expand and evolve as you find new ways to take advantage of it. But getting started with service workers is surprisingly easy. The first thing to understand is how it works and what it is there for. A service worker is essentially a JavaScript program that runs in the user's browser in a separate thread compared to the main application code. Its primary use is as a kind of proxy server that sits between the main application code and the network. What this means is that once registered successfully, it can intercept requests made from that page and gives the developer complete control over how those requests are handled before they ever hit the actual network. The clearest application for this is handling situations when the user has poor or no connectivity. The service worker can be configured to respond with cached or fallback content, and if done properly, the user will never have to see the browser's offline page when visiting your site. Service workers can also be used to improve performance, cleverly combining with cache APIs to make every interaction with a backend return cached content, for example, even when the user is online. But service workers have other properties as well. They run in the worker context, so they do not have access to the DOM. direct access, but they can communicate with the main app code through post messages and events. They also are fully asynchronous, meaning that synchronous APIs like XHR and local storage are not available within Service Worker. And finally, they can run even when the parent tab has been closed, allowing previously impossible implementations of features like background sync and web push notifications, even when the user has your website closed. So background sync, which is kind of what we can see here, would be something where you've stored, let's say, user actions while they've been offline until their device goes online again. At that point, the user doesn't have to visit your website in order for you to sync up with your backend. The service worker will be woken up by an event listener within it, and it will be able to communicate back to your backend with all the interactions that your user had. So, how to set it up. Now that we've touched on the basics, let's have a look at what it looks like to actually create one. In order to do that, we're going to use this simple example application right here. The first thing you need to do is create the file in which we're going to write our service worker code. Once you've got that file ready, it is important that you host it from the root of the domain that you want it to control. Service workers have a specific scope, and that scope is defined by their origin and path. You can override this behavior by configuring the registration step, if you so desire. Now that you've got your service worker hosted on your domain, it's time to hook it up with your main page. This step is called service worker registration, and the code generally looks something like this. First of all, you want to check if the service workers are supported by the browser, and then, if they are, call the register method on the service worker object, passing it the path to the file we created in the previous step. This method returns a promise and will trigger the browser to download, parse, and run the service worker file. At this point, it's worth noting that in the first run, even though the service worker download, parse, and execution will happen in a separate thread, it is still important to consider its impact on underpowered devices and networks. For example, if during installation your service worker downloads multiple resources, this may cause bandwidth contention that will impact the speed at which the main page appears to load to the user. This is the opposite of what we are trying to achieve. So a better registration snippet might look something like this. This only registers the service worker after the main page has finished loading. In general, make sure you're constantly measuring your website's performance so you can make the best decisions about where and how to optimize. So, we've got our service worker registered for our page. Let's get it to do something now. Let's improve subsequent visit performance and get our page to work completely, even when the network is unavailable. Remember, this is just a simple example of what this could be set up to do. What we're going to do, we're going to add an event listener for fetch events in the service worker. When the worker is active, this event is going to be triggered for every request that originates from our web page. That will even include the first request for our HTML file, which is exactly what we want if we want our site to work, even when the network is unavailable for whatever reason. In this event caller, we are going to do a few things. First, we access the browser's cache storage API. You can see there's a version number there as well. That's there because during the update process, you may want to have different versions of your caches. For example, if you change your service worker and your website has changed dramatically, you might want to use a new version for your caches. That means that the old sites will continue to work and the updated sites will use the new version. Next, we're going to try and retrieve the resource requested from the cache. If the cache resource exists, we're done. We use it as the response. Otherwise, we try to request it from the network. Once it comes back, we save the value to our cache and respond to the fetch that we intercepted. We haven't done any error handling in this code because I wanted it to be readable for the slide. But the beautiful thing about service workers is that it is a program that you write. So it is completely up to you how you want to handle any given situation. This is in contrast with application cache, which in the past was used to provide site caching and offline capability. The problem with app cache, though, was that it was extremely rigid. Your use case needed to match what it expected exactly. Otherwise, as Jake Archibald puts it, you're losing the app cache lottery. So with service workers, spec writers no longer try to predict how devs would want to solve caching, but instead, they give them access to the tools to solve that problem for themselves. Before we move on to talk about the next bit of PWA tech, I just want to briefly touch upon the service worker lifecycle. With a piece of code we've written so far, our app will only work offline after the second time the user visits. That's because on the first visit, the service worker will be registered and installed, but it'll only become active the next time the user visits. This behavior is also overridable, but I won't go into that now. So, back to our example. On the second visit, the service worker is active and will cache all responses, so that from then on, when the user hits your web page, they'll be instantly greeted by your wonderful site, whether they're offline or online. How you want to handle the service worker lifecycle is again up to you. What's great about service workers is that they give you really granular control to manage this area of your app in the most appropriate way for you and your users. So, wrapping this up. With this setup, we've really just skimmed the surface of what a service worker is capable of. But even so, we've managed to get our simple site to work offline in a controlled, extendable, and updatable way. When you start implementing service workers for your project, I highly encourage you to head on over to the Mozilla, Microsoft, or Google developer portals, which have some excellent tutorials, articles, best practices, and general reading material that I personally found incredibly helpful. Okay, we're done with the service worker. The next step for our PWA is to create the web app manifest. The manifest is just a JSON configuration file, which you will probably have to set up once and then not have to deal with much after that. To add the manifest to your site, we link it in the header of your page's HTML. First of all, you're going to want to give your PWA a name. You can also give it a short name as well, if that makes sense. Short name can be used by the OS when it thinks there's not enough space to show the full name, like on the device home screen, for example. Then you can define your app's theme color, background color, and icons. These are generally used to generate the splash screen when the app is added to your home screen. Regarding the icons, MDN suggests that you at least add the one 512 by 512 pixel icon to adequately cover all use cases. If you want more granular control of the icon appearance, you can add more sizes to the array here. Next is the display property. With this, you can specify whether your app should appear full screen when it opens from the home screen, in standalone mode where you get the status information from the device, or simply as a regular website with a full Chrome when it opens from the home screen. Finally, the last bit of config you're going to want to define is your app start URL. This URL is going to be navigated to when your users click your app's icon on their home screen. So make it the most appropriate URL where they should start the journey on your site. Another thing that's often suggested here is to add a tracking parameter to the URL so that you can measure how many users are tapping on that home screen icon of yours. The manifest has a bunch of other properties like orientation and language, and I'm not going to go into these here, as I just want to give you a working taste of what can be done. But if you're interested, head on over to the excellent MDN docs to get the full picture of what's available. And we're done with the manifest. So now you've got your site working over HTTPS, you've created a service worker for it, and configured your app manifest. You are now ready to have your app added to your user's home screen. In fact, the behavior in browsers that's supported right now is that when the above criteria are met and the user has been interacting with your site for a given amount of time, the Add to Home Screen prompt will appear automatically. Once the user clicks Add to Home Screen on the prompt, your site will immediately be installed. That's it then. That's all you need to do. However, this automatic prompting may confuse users who don't expect it. And because of that, browsers are in the process of trying to change this to encourage developers to take control of this interaction for their own applications. The way this will most likely work in the future will be something like the following. On the page with our manifest and our service worker, we'll have another snippet that attaches a listener for the before install prompt event. In there, we'll prevent the default behavior to cover not showing the prompt on older implementations, and then we'll attach an event listener of our own to something like a custom install button that might exist on the page. This way, your users won't be suddenly blindsided by a pop-up appearing out of nowhere. The rest, in terms of building your PWA, is up to you. We've got the capabilities of PWAs do not stop there. As I mentioned earlier, one of the core tenets of what a PWA should be is re-engageable. Now that we've got our service worker set up, we can implement push notifications for desktop and mobile to bring people back to our sites. I'm not going to go into the details of how to do this, but you can find many great tutorials online on the subject. Another great piece of new tech available in some browsers is the WebAuth API. Starbucks is already using it in their PWA in browsers that support it, and it allows them to improve their login flow dramatically with things like one-click sign-in and even biometric login. Alternatively, you could choose to focus on leveraging the browser's APIs for web payments that will be bringing support for card management, Google Pay and Apple Pay, and more to websites and apps in the very near future. Or you can choose to explore a score of other exciting new APIs like speech recognition, augmented reality, background sync, and more that are now quickly becoming more widely adopted. Head on over to What the Web Can Do today to see what's available. And if you remember all of the above, a PWA is progressively enhanced. You'll be able to deliver great experiences to users in both supporting and non-supporting browsers. And as each browser implements the new spec, your users will automatically be upgraded to the excellent modern experience that you've put together. So, is there anything to make this stuff easier? Like I said earlier, one of the three great things about PWAs right now is that there's a lot of ready-made tooling available to you. For moving your site over to HTTPS, you should honestly look no further than Let's Encrypt. It is free and probably the most straightforward way to add SSL certificate to your website. DigitalOcean has some great tutorials on how to set this up on a variety of Linux boxes. That's how I got my site done. Next in the list is Microsoft's PWA Builder. This site is a really handy wizard. It has a CLI version as well for creating your web app manifest and service worker from scratch. I'll walk you through filling out all the necessary details, explaining at each step of the way what each option does and how it will affect your PWA. The great thing is that once done, you'll not only get the files necessary for your PWA, but the site will also walk you through submitting your newly minted progressive web app to the Windows App Store, should you be interested in that as well. Now, if we're looking for a library to reduce boilerplate in your service worker code, then look no further than Google's Workbox. Successfully deployed in Starbucks' progressive web app, among others, it contains helpers for many common service worker patterns. Using Workbox, for example, the little service worker code I showed you before would essentially be reduced to a one-liner. Along with these tools, there are a whole host of other resources available as well. From specific tooling for every framework, including React, Preact, Angular, Vue, Polymer, and anything in between, to great tutorials, guides, and articles. Finally, I would be remiss if I did not mention the incredible amount of work that has gone into creating excellent debugging tools from PWAs. I unfortunately do not have the time to go into this subject deeply, but all browsers have introduced debugging tools for progressive web app. Google have also been working on a variety of checks in their excellent auditing tool, Lighthouse, which is now included in their integrated browser development tools as well. So whatever you do, definitely run your site through that and check out what comes out. I didn't talk about this much yet, but I do want to make sure I've highlighted before I close my talk. Progressive web apps are most definitely not just for mobile. Desktop is just as much a platform for PWAs as mobile is. In fact, when Starbucks launched their PWA earlier this year, they were surprised that a much larger than expected number of their customers ordered coffees from their desktops. Even though the mobile web is growing every day, and has even surpassed desktop in many usage metrics, desktop still amounts to about 41% of daily usage, so it is by no means unimportant. Mobile versus desktop usage percentages also differ greatly depending on the time of day, with desktop usage peaking while people are working at their offices and mobile usage peaking when people are home relaxing. That means when you're choosing technologies, it's important to factor in how you expect your users to interact with your apps. Another clear proof that web technologies are a valid choice for desktop is the influx of Electron apps over the past years. Slack, Microsoft, and of course GitHub, among many others, have Electron apps with multi-million user bases. Electron works by packaging a browser engine along with your application and running your code through that. Compared to a PWA, it suffers in a few ways. One, Electron is desktop only. If you wanted to deliver a similar experience for your mobile users, you'd likely need to do a lot of rework. Two, every Electron app that is installed has packaged an entire browser engine along with it. That's wasteful considering the user almost certainly already has a browser installed on their desktop device. And moreover, unlike the user's browser, the one packaged along with the Electron app will not be getting security fixes unless it is manually updated by the app developer. And finally, the thing way too many people are interested in. How does PWA compare to native applications? In my mind, these two things are apples and oranges. They're both fruit, but they're good and bad in different ways, and one is not really better than the other. I know that may sound like a wishy-washy answer, but that is the truth in many cases in software development. The answer to these types of questions is almost always, it depends. Just think about, for example, how many front-end libraries we have. Progressive web app tech is built on the web. It gains the incredible distribution of the web. Your single site is available to anyone on any device, on any platform. You can update that site without paying the price associated with walled gardens and app stores. Your updates will go out to your users as soon as they get an internet connection. You don't need to force your users to download your entire app so that they do that one thing they really wanted it for. And it's easier to share a link than share a resource in an arbitrary application. But will a PWA be able to compete with all the native capabilities of a native app? No. There are almost certainly always going to be things that native can do better than PWA. Does that mean native is better? It depends, right? Do you really need that thing that native can give you that your site can't? Is it so crucial for your business that it becomes more important than the massive reach that your PWA will have? And even having said that, are you willing to leave users on the table? Before Flipkart built its PWA, it tried out a native app-only strategy. And it found that it was losing out on an incredible number of users who weren't willing to download the large native app on their constrained devices. PWA saved the day for them. It did everything they needed it to do in a package that was tiny compared to native. But that is Flipkart. What is best for your business? PWA tech undoubtedly should change the way you write for the web. Offline first should really be the next mobile first. And the future, I'm sure, will be an amazing place for the web. I'm extremely excited to see what more this year will bring us, and I'm extremely excited to see what each and every one of you will be building with these technologies in the future. Thank you for coming to hear me out. I hope I did this topic a good service. Thanks.
I don't think we want to let you go just yet.
Sorry?
I don't think we want to let you go just yet, Max. So I want to give the microphone to our friends and see if we can have any questions from our audience. Is there a hand somewhere up there? No hands? Max, thank you very much.
Thank you all.
Thank you.
Thank you.